In this lesson, 6.2, we'll be using proportions to solve geometry problems. We previously looked at a key property of proportions, the cross product. We now look at two other properties. One is a reciprocal property. If two ratios are equal, then their reciprocals are equal. All this really means is that you can write these as you see them. Instead of putting gas over oil, you could put oil over gas as long as you are consistent on both sides of the equal sign. In a proportion, if you add the value of each of the ratio's denominators to its numerator, then you form another true proportion. We'll see how this will be used in example 1. Basically what it's saying is that if the two parts of line segments are proportional to each other, then the entire line segments will also follow that same proportion. So let's look at this and see what it's saying. What this says is that BD is to DA, so the top part of this line segment to the bottom part is proportional to BE to EC. And it wants me to find both the entire length of BA and the segment BD. Well, we can set up the proportion just like it was given to us. Now, if we're looking for x, that entire portion, notice that it's made up of BD plus DA. So that's what we'll do on this side. We'll add these two together for our x, and we'll add the other two together, BE and EC, to match up with that. And what that means is that our x over 3 is proportional to the entire length of BC, which is 18 plus 6 over 6. So then we can do our math and find out that x is 12. If that whole length BA is 12 and DA is 3, then the other part is 12 minus 3, or 9. So you can see what that property, it may look complicated, but what it really does is simply say you can do part to part or the whole thing to a part. You can set these proportions up the way that you see fit. The blueprint shows a scale drawing of a cell phone. The length of the antenna on the blueprint is 9 centimeters and the actual length is 2 centimeters. What is the scale of the blueprint? Well, blueprints have scales, maps have scales, and generally what they do is they write it as a proportion and then they actually reduce it so the denominator is 1. So in this case, 9 centimeters over 2 centimeters, when we reduce that by dividing both by 2, we get 4.5 centimeters to 1 centimeter. So that would be our scale. Every 4.5 centimeters on the drawing is actually equal to 1 centimeter in the actual cell phone. So let's do our guided practice. Remember, you may want to pause and try here before you do it. Let's see. We were looking for DE. It says that DE is proportional or is to AC as BE is to BC. So let's see how we can plug in for that one. What we get is DE is 12. Excuse me, didn't have my pen turned on. DE is 12. AC is what we're looking for. BE is 18. And BC is this entire part, so that's 18 plus 6, which is 24. And when you work that out, you will get 16. The next guided practice, one for you to try, is what if they said that the blueprint had 10 centimeters for the antenna, whereas we know the real one is 2 centimeters. Well, we simply say 10 centimeters compared to 2 centimeters and reduce that to b over 1, so it would be 5 centimeters to 1 centimeter. And that would be our scale factor in this particular case. When we're looking at a map, As I say, a lot of maps have scale factors. It tells you that 1 inch is equal to 26 miles. So I can say that 1 inch goes with 26 miles. Now I'm not going to have to convert miles into inches here as long as I'm consistent on both sides. So I'm going to put my 1.25 inches on top, since I have that, inches on top on the left side, and what I'm solving for is x miles. And so I can simply let me get this out of the way. I can simply write this up and then solve by doing my cross product. Turns out that it is 32.5 miles. Two cities are 96 miles from each other. The cities are 4 inches apart on a map. Find the scale of the map. So what we have is that 4 inches is the same as 96 miles. Therefore, 1 inch is 24 miles when I reduce that.